Okay, let's talk about the general idea for this lab. So it's going to start in equilibrium, which means everything is balanced. And then it's really a simple idea. If I apply a force that's some distance from the axis of rotation, if I apply a perpendicular force to the lever itself, I create torque, which the big idea with torque is it gets things to rotate on their own axis of rotation. Once I stop applying that torque, though, you can see it goes back to being balanced. So we're not going to do this by you guys pushing. We're actually going to do it by hanging objects at certain locations. Because if we hang something like a washer, all right, if we know its mass, we can calculate the weight that's pulling it down. And if you think about it, that's perpendicular to the lever itself. So we can just then do the gravitational force times the distance it is from the axis of rotation, and that'll give us the torque. So the easiest way to set this up, I think, is to take our smaller strings that we did the double loop with, and if you take it around the ruler and then feed one end through the other, like I showed you the other day, you can then actually kind of have this slide wherever you want. It's pretty nice. The string doesn't really have too much mass, so you can see it didn't really influence the torque, but believe it or not, the paper clip itself, which I want to hang down here so that we can hang things like the washer from it, or maybe a Ziploc bag to put the tennis ball in, like we did in another lab. The paper clip, you're going to see real quick, actually is enough mass, which then has a force, where it gets it to rotate and makes it on balance. All right. The paper clips are actually 1 gram, so that is enough force when you then calculate its weight. That's enough force and torque to get it to rotate if I have it far from the axis. So what you might have to do then is you might kind of just have to put it at the middle when you're setting this up, because if it's not a distance from the axis of rotation, there's no torque. So then if I'm trying to set up another one, this will make it easier. I can actually then just come over to this other side and get this one set up. All right. So I think that'll make it easy, at least when you're trying to get multiple on there, to just put them at the middle. Same idea then, of course. Oop, get off the rubber band. Oh boy, I'm losing it. Same idea, once I put the paper clip, if it's not at the axis of rotation, there's going to be torque, and it's probably going to start to rotate, yep, that way. Okay, so it's probably safe to just put them near the middle where there's less torque. And if they're the same distance from the middle, then they're actually going to create the same torque because they're identical paper clips. Be mindful, the middle, if we do this all together, the middle looks like it's going to be at 14 point, let's go 7 or 8. I'm fine with either, you choose one. Looks like 14.7 centimeters is the middle. So let me give you a scenario. Let's say we're going to actually do the big washer. Okay, 10 grams, convert it to kilograms, find the weight. If I actually then hang this 10 centimeters from the axis of rotation, this fulcrum, I'm then going to have a torque. All right. What's kind of cool though is if I think about it, that'll put it at 24.7 over here because 10 from the center. I can balance that by doing the identical washer 10 centimeters on the other side, which would be at 4.7. So watch this. If I hang this one and let it hang over here, I'm not going to let go because clearly there's a counterclockwise torque that's going to unbalance everything. But if I hold it and then get this other one set up, all right, I can then actually think about the idea, well, if there's a torque from this weight at this distance, if I have the exact same mass, so same weight, I can put it at the same distance on the other side, 10 centimeters away, and voila, everything's balanced. So this is kind of an easy setup for you. Of course, we could do different masses where one of them will be at a different distance then from the axis of rotation. And I could even introduce a third one. So you should be able to make a third double loop string with the remaining string that you had from cutting these. You could actually add a third one in here as well and hang other things. Keep in mind, if I ask you to basically hang something like the rubber stopper, the toy car, or the tennis ball, we'll actually then hang the bag from the paper clip itself. Just a heads up, the paper clips are 1 gram each. Believe it or not, the plastic bag is 2 grams. So this will actually create its own force when you just hang this from the paper clip, which then if it's applying a force, it's creating a torque if it's some distance. So this is very sensitive. The rubber band, of course, was used to balance it. So be mindful of even small masses and weights like the paper clip and the plastic bag, okay? All right, follow the instructions for the lab. I'm gonna make you do a couple scenarios, and hopefully you guys can find the answer, whether I ask you for where does something need to be hung, or if I ask you to find the mass of something that's unknown. I think you guys can meet this challenge, okay? Good luck, everybody.